All right, 55. Athletes performing in bright sunlight often smear black eye grease under their eyes to reduce glare. Does it work? In one study, 16 students took a test of sensitivity to contrast after 3 hours facing the bright sun, both with and without eye grease. This is a matched pairs design. Here are the differences in sensitivity with eye grease minus without eye grease. So with eye grease, so let's write this down. With eye grease minus without eye grease. Okay, so go bigger here. So these are tests of sensitivity. Um, so we have to kind of figure out what in the world is this saying here. Um, so matched pairs design is a before minus after. Okay, that's what that means. So we have the same guy that they test the eye sensitivity with eye grease and then without. Okay. Um, what are the null and alternative hypotheses? Say in words what mu is, and then go from there. So it looks like, does it really say what these numbers mean though in the problem? Just kind of thinking out loud here. Okay, not really. Does eye grease increase sensitivity on the average? Well, if there's no change, then mu would be 0. So H0 mu equals 0. This means eye sensitivity is the same with and with and without eye grease. Now, if the eye grease helps, then eye sensitivity should be better, right? So this number would be greater than this number. Okay, that's what I'm assuming is the case, that the higher the number, the better the eye sensitivity, because it's eye sensitivity to contrast, as I just noticed right there. So the higher the number, the better. So if the eye grease works, then that number should be higher than this number here. So if it works, we would expect the average to be a positive number, right? So with eye grease, or I should say this, not with eye grease, but eye grease works. The sensitivity numbers are higher with the grease. Okay? Alright, so there's a null and alternative hypothesis. Alright, say in words what mean mu your hypothesis concern. So mu is the average difference in sensitivity to contrast from eye grease minus no eye grease. Okay, so there's A. And B, we want to actually, it looks like, do the test. Suppose the subjects are SRS with normal vision, contrasts are normal, and sigma is 22. Those are the conditions we have to have. So do the test of significance, or do the hypothesis test. So this is going to be a Z test. And so I'm going to go ahead and I actually have the data in my calculator off screen here that I will do. Stat test, z-test. So I got stats in here. Mu0 is 0. Sigma is 0.22. I'm sorry, it's data. Jeez. Data. Mu0 is 0. Sigma is 0.22. List is L1. And mu is greater than mu0. Calculate. And if you do that, you get z is equal to 1.8. The p-value is 0.033 or 3.3%. So since 3.3% is less than 5%, I have evidence for HA, but in context, that the iris does in fact increase sensitivity. Okay, does that make sense? All right. Hope so. If you have any questions, talk about it in class. Thanks.